I want to just keep things really simple and just lay out some of the focuses that we want to go through today. Now, the first thing being that this is, we're dealing with talking about preemptive programming, then I want to kind of bring up some of the differences between cooperative and preemptive process to kind of lay down the foundation of the discussion a little bit. And then we'll go on and talk about how to audit your code and making sure that they are preemptive ready. A lot of you guys have code that's been written and deployed for so many years. Sometimes you kind of have to go through many things to find out whether they are preemptive ready or not. And we'll go through some of the process that you have to do to be able to identify whether they are or not. The next thing will be, I want to bring up some use cases because there are some use cases that are appropriate for preemptive, especially between using call workers or new process. Some of them can be thought of differently in terms of the use case. So I'll talk about it a little bit more. And then at the end, we'll go through some of the new features. I know Laurent already covered a lot of the stuff. This is kind of my take on the features and just to touch base on how the feature actually works and to give you maybe just a different picture of explanation. Okay, now the first thing we're going to go over is process. And to be precise, the differences between cooperative and preemptive processes. Traditionally, we always talking about cooperative process because for the most of the time when we see 4Ds running, we always think about, the process is running, whether the UI or the background process. This is prior to the introduction of the preemptive process in 4D. So cooperative is something that we actually refer to. Okay, so I want to kind of start with something simple. I have both sides here, cooperative on the right, preemptive on the left. We'll go through them one by one. Now, cooperative process usually refers to all the processes that share within a single CPU. Basically, they work together, they're sharing resources. 4D can only allocate all of these processes to run within the CPU. And all of them has to yield to other, meaning that let's say you have two processes running, then one of them will have to give time to other after its execution, and then the next process running for a while, it has to give time back to another process to run. So they're actually working together, kind of sharing the resource. Now, I'm actually stole this diagram from Laurent from last summit. I thought it was really good demonstration of how it actually behaves. So given two CPU here, I'm giving it a timeline. Let's suppose that we have two processes running, starting almost at the same time. So the first process will run for a little bit. Now this could be just a 4D process running internal or your own process, doesn't really matter. The concept is the same. After a while, whether the tasks have been completed or not, you should always give time to other processes by calling idle command. Now in 4D itself, it does that as well. It performs some execution. Maybe it's not yet finished, but it needs some more time. It gives time to other to perform the task. So In this case, the second process now has a chance to start its own execution. After a while, it has to yield back, that is, give the time back to the other process, and the other process will just pick up on where it's left off, continue for a while. Let's say if it's finished or at this point, gives the time back to the last process. So as you can see, the overall time actually can go pretty far. The consumption of the overall time and can be quite big. Now, on the other hand, we have a preemptive process. Now, preemptive process basically allows each process to run, in its own CPU. That is, if you have multiple processes, each one of them could be running simultaneously in its own CPU space. And the OS actually helps to decide which CPU is available to run your process. You don't really have to think about it. This is handled by internal. I'm going to go back to the same diagram. So right now we are ready to run preemptive processes. Again, given the same scenario, we're going to start two processes just almost about the same time. But this time, the picture is going to look like this, right? There's no yielding because for a process that's running in the preemptive mode, it basically take up all of that execution time until it's finished. And then, once it's done, it's done. So this way, we have two CPU there. Each one is take up the space from within each CPU. This way, you can see the overall execution time actually much shorter than the last picture. But this is only two processes. Now, this is another picture. Let's say you have more than one process that's running at the same time. So, they're not stacking up into a really long period of time. Each one of them takes one CPU and then execute in its own space. So this way, all of them can finish in a shorter overall amount of time. The restriction, of course, the preemptive process, it does not allow you to have a user interface. It means that it should run behind the scene. It can't even display an alert box or anything like that. Anything that deals with user interaction, those are going to be running in a cooperative thread. Okay. So in 4D, there are two commands that you can spawn processes from. One of them is the new process command. We've we have been using this command for so long. And when we introduced the preemptive process, we introduced workers. So call workers, that's another command that we can use to create a process. Now, both of them can be executed in either cooperative or preemptive mode. You choose which one you want. For new process command, the execution will end as soon as the whole method execution, not execution, the process will end when the whole execution is finished. Let's just say you have 5 lines of code. You hit line number 5, and then you're done, the process gone, right? Most of the time we use this command to run some kind of a stored procedure. So to maintain the process in the background, then we'll do some kind of looping mechanism to keep that process alive. For call worker, the process actually does not end until you tell a tool when fully quit. If you issue a new worker that is executing maybe the same thing, 5 lines of code, after you finish line number 5, the process actually being put on a standby is being maintained by 4D. It also kept the context of your execution too. For example, if you have a selection created for some table in that worker process, even though the process execution has been completed, because the process maintained by 4D, it also maintained that selection as well. So the next time when you come in, that is calling the same worker again, you will be able to, if you want to, take advantage of that selection that you have created earlier without having to repopulate the selection again, or even a variable. If you populate some kind of an array, a text variable, everything also maintained by 4D. Now, on the new process command, so when we create a new process, normally you will see that there's a star parameter at the end. If you don't specify the star parameter, it means that the process is always going to be spawned as a new process. Even though you name it the same one, process 1, the next time you call process 1 again, that is calling the new process command to process 1, without the star parameter, 4D will create a new process for you. Versus call worker. Call worker is pretty, it is exclusively unique to the name. So if you name your worker, worker 1, the next time you call worker 1 again, it uses the same exact worker because the worker doesn't go away after it's finished its execution because 4D maintains it. The next time you call it, it reuses the same worker process. I'm going to give you just a simple comparison between the new process command and the worker commands. And I'm going to use the scenario of calling these three lines for each scenario, for each command 3 times in a row. Okay? So we'll start by using a new process. So you can see, let's suppose that my method is thread save, that is going to run in preemptive mode. And I'm also naming my process the same exact one, right? So line 1, 2, 3, calling new process. I name my process, new process the same one. But because without the star parameter, it's going to look like this. So process 1 executed for the first line. It's going to go to CPU number 1 because this is preemptive execution. If I'm calling the second line, again, let's say process 1 is, again, even though it's the same name, but the new process command it's not like worker, right? It doesn't use the same process, so it creates another process. Now it's going to run in second CPU. The third one, again, because they are separate processes, they are different processes, they're running in its own CPU. Okay? So a different picture now using the command called worker. All of the workers' name has been specified with the same one, so let's see what happened here. The first execution, okay, the workers process gets created and it runs in one CPU. Well, now the second one comes in, it actually, because the first worker is not finished yet, okay, in this case I'm using yellow to show that it's still running. So the second line of execution actually going to call the worker, but because it cannot occupy the worker just yet because it's not finished, it goes into a queuing system. It's almost like a mailbox, right? So it's going to wait for the workers to complete its own execution before it can go in. So if I call the next line, which is the third one, now it goes into the queue again until the first two have been completed. So I'm not utilizing all the CPU at all for this scenario, as you can see. I'm actually, executing everything within one single CPU. So if I want to separate them up into multiple CPUs, then I have to change the worker's name into its own unique name, right? So now CPU 1 is running process 1, CPU 2 runs process 2, and CPU 3 runs process 3. Okay? All right, so the next thing is, again, this is quite important for many of you, being that you have database that's been around for many, many years. How do you know if your code is preemptive ready? In other words, we can call it thread safe, right? How do you know? So again, the term thread safe, this is nothing new. This is part of the programming multi-thread coding concept. It basically implies that if your code is thread safe, your code should be able to run simultaneously by multiple threads, not just one. And it should also free from any kind of race condition that should produce no contention. Is actually, that's one thing that is pretty unique about running preemptive. The execution should be isolated. That is, once you tell the worker or the process to run in preemptive mode, it runs. You don't really care. It handles whatever it needs to handle by itself, right? It doesn't wait for anyone else, or no one else should wait for this process to be done. Now, going back to this morning that I brought up, again, in version 17, there are over 1,000 commands now that are thread safe. This is really big for us because you now have more options to change your code or apply your code to run in preemptive mode. So it makes it easier now. Along with that, again, with the storage and the shared objects, shared collections, this is something that's going to come in really handy, especially those of you who are using inter-process variable, or even something like the command set process variable or variable to variable command. Those are no for preemptive programming in 4D. So using these feet, the new shared objects or shared collections will come in really handy when you're trying to make changes to your existing project. Okay, so there's some rules that you have to follow, making sure that your code or your methods are considered thread safe. Now, one of the things that you will notice right away when you open up the method editor, you'll see there's an option in the middle of the screen right there, execution mode. And this option only applies to your database when you compile your database, right? If you never compile your database, you deploy your database and interpret it, you will never benefit from preemptive programming. Everything runs like in Cooperative. There's no multi-thread execution going on. So just so you know, I know some of you are still running your database in interpreted, so that's one thing to be aware of. The first option that you see there is basically tells 4D that your method will be forced to run in preemptive mode. And the detection will come in during the compilation. I'll show you in a little bit. Okay, so there are some 4D commands that are considered thread unsafe. The most obvious one would be anything that deals with user interface, anything that deals with user interaction. Like I said before, something like an alert command, anything that deals with the form object, those are considered thread unsafe. The commands such as set process variable or variable to variables are also considered thread unsafe, so avoid doing that. Again, with the object share objects, you have an option to migrate your code away from it. Similar to before, anything that's opening the form or windows are not allowed. They're considered thread unsafe. Okay, now if you have a method that you are calling from another method, now that whole chain of call needs to be, the whole thing has to be thread safe, right? If one of the methods are considered thread unsafe, the whole thing is thread unsafe. So be very careful in terms of how you construct your call change. But during the compilation, 4D will tell you what is wrong with it, and you will have a chance to go and make correction during that time. The begin SQL and end SQL, this is still not yet made it to the thread safe command set. So just hold on tight for those of you who are still using it. We're working, again, step by step. So eventually, hopefully in the near future, you'll see something that will allow these commands to, go ahead.
Sorry to interrupt, but I thought the SQL queries run on preemptive as well.
Not from the language.
Okay.
Yeah.
All right.
Okay, so the obvious one, this is the popular one, the use of inter-process variable. They were not allowed. And finally, any of the plugin calls still being executed in cooperative process. Again, Randy was talking to me earlier, so this is something that, again, it's a step-by-step from the engineering standpoint. We were trying to address some of these restriction from blocking you moving some part of your code to preemptive. Just so we have this list, at least you guys are aware of what are not allowed, and the rest are kind of free for all. Okay, so this is the process on how you determine whether your database or your codes are thread safe or not. So a couple of techniques here. So from the structure of Windows, right? If you go to compiler setting, the second option there, the first thing you want to do is to enable the option to generate a symbol file. This comes in very handy when you want to find out more about your database and your methods and stuff like that. And you'll see in a little bit when we show you the compilation result. So after you turn that option on, and then you go ahead and do the compilation, you'll get a file sitting next to your database structure that looks something like that, with the database name underscore symbol.txt. And if you look inside the content of that file, when you scroll down to the bottom of the file, you'll see a block, the whole block of your methods, right? All of your methods will be listed there. Whether they are considered to be function or procedure, they will all be there, okay? And the cool thing is that it tells you which one are thread safe, right? At the end of each line, it will tell you thread safe. Also, it will tell you which one are not safe as well. Thread unsafe will be listed there. And this way, if you want to, you can just go directly to that method and try to work with it, right? So this is one option that you can find out what part of your database that is still needs to be worked on. Now let's go back to the method properties. Excuse me. Now let's open up the two methods that we saw from the symbol file, right? So we have load CPU activity and another one, open monitor. At the moment, the 4D, we have the option set to indifferent, meaning that 4D doesn't really care whether this method is safe or unsafe during the compilation. It's not going to complain. So if you run the compiler with these option, with this specific option enabled, compiler will just say, you are clear, go ahead, Now, let's go back. If we force it to use the first option, which is tell 40 that, hey, I want to execute this method in preemptive mode. And then you went ahead and do the compilation. Now you get an error that tells you that there's a problem there. It also tells you which line that you need to address the issue. This is quite important because of, sometimes just looking at the symbol file alone, it doesn't really tell you which line and where you need to address the issue. The compiler will tell you specifically where the problem is. And then it's your responsibility to go through that process to address the issue and make changes. Okay? All right, so I thought it would be a good idea to just kind of bring up some use case and some consideration when you want to go preemptive. Now, ideal operations based on kind of my own research, talking to people, and it usually deals with anything that can run independently, right? It's not something that requires other process to finish, or there's no waiting for anyone else to complete the task. So once the process is spawned or was asked to execute something, that task needs to be sort of a self-contained kind of task. In other words, we can have a process that is a non-blocking process. A lot of time you'll see people using preemptive process in a batch operation. You want to have a lot of stuff being executed, computation. A lot of this stuff could be something like reporting, data processing, transaction, data integration, and stuff like that. Anything that requires sometimes that you don't want it to consume or take away the resource from the main core or the cooperative thread. So you spawn it out to another preemptive process to run in its own space and let it be. So last year, I wrote this tech note sort of based on some of this discussion that I had with some of you guys over the note. So I thought it was a good illustration of how to utilize preemptive programming using the workers and stuff like that. It's available now. You guys can download it. It's basically using the concept of generating a log file onto the disk, right? By using the worker, I was able to have a more simplified code that I don't need to deal with contention and stuff like that. And I have a more precise of the order of what is happening, at any given time. So that's the link to the knowledge base. You guys can download it. I'm sure all of you or most of you are partners. So the idea behind it is kind of like this. So let's say you have multiple processes, right? And it can be anything. And you want to log the information to a log file, a single log file. Now, without using the workers, the picture would be something like this. For each process that needs to write something, it has to kind of communicate to the log file directly, right? At the same time, it needs to block anyone else from accessing the log file. It means that you have to place your own procedure to avoid any kind of contention, for example, using semaphore again. So I was trying to avoid having to deal with that type of situation. So instead of doing this kind of typical things, I placed a worker process in the middle, right? This way, all of these processes can immediately send information to the worker. And from the picture that you saw earlier, because I'm working with one single unique worker, everything that comes in that is not yet being processed is going to a queue. It means that now I have that ordering system going on. So once the worker sends something to a log file, it picks up the next item. process it, send to a log file, picks up the next item. So, and the log file doesn't have to be closed and open, closed and open. You open it once, that's it, because the worker will continue to keep sending information to a log file. So it's kind of helping my code to be a little bit more refined and helps me with the managing of the contention and where things go and when it's going to happen. Okay, so this is going back to the conversation about sharing information. Again, like I said, you guys are going to be probably looking at this heavily after the summit, I'm sure. There are two commands that deals with shared information. So we have shared objects and shared collections. Both of them are quite the same. I mean, except that one is for objects. Object variable. The other one is for a collection variable. Now, I'm just going to keep it simple and just go ahead and keep the discussion only for the shared objects, okay? The concept, again, it's the same. You guys, when you look at the command and go through how it works, you're not going to have a hard time understanding how it works. So I'm going to give you just a simple example. So here's a method. I want to run this method and create an object that I can share with other process. So let's say I'm passing my object to another method like that, okay? And I'm calling a new process command to spawn a new process and sharing the, with the object variable passing in. Just like what Laurent said earlier, traditionally, if this object is not initialized as a shared object, a copy of this object will be sent to another process. But because this is a shared object, right, it has a unique property. So 4D actually is sending the reference of this object to another process instead of the copy. Same thing as worker, it does the same thing, because the concept of passing, this is another form of process, so it behaves exactly the same. Okay, so let's do a quick example here. So we have an object, A, two properties, text and number. To read from it is actually quite simple, right? We just do dot notation, or if you want, you can do the command obget, and that's okay too. Now, if you want to write, it means that you actually have to ask for permission. So we have to make a call to use command and use object A. That basically tells 4D, I want to make modification to object A. Doesn't matter what you want to modify, you have to tell 4D from the parent level, okay? So here's another picture. Let's say you have, go ahead.
Just curious, will an error be, if you forget to do that, what happens? Does an error happen at runtime, or does it not compile, or what if you forget to state the use before assigning?
You will get an error.
Okay.
Yeah. So an object also can contain another object or sub-objects, right, multiple level. And all of these, once you have the parent set to shared objects, again, if you want to read even from the inside, you don't need to ask permission. You can just reference it directly in that manner. Object A dot object B, using a dot notation to go directly to that item. If you want to read, you can do some write. No, not read. If you want to read and you're not sure if what you're reading is actually there, same thing that you saw from Laurent. When you do a comparison in like this, either you use equal or not equal, you can compare it using a null function. Basically, it compares to see if what you want to check exists or not. Because in this case, for the comparison, null is equal to undefined. So whether it's undefined or null, it's the same. And for you, you only care whether it has the real value or not. So you can use that kind of approach to check before you actually access the actual information. Writing, again, applying the same thing. Let's say we check at the top level to see if actually name inside of object C is actually there. Maybe if it's there, maybe I want to make some modification. So in order for you to modify something inside of a shared object, you also have to call the use to that level also. So in this case, we call the use command and put in object A dot object B and dot object C, and then we can modify name property within object C. At the same time, when you make a call to use to object C, even though it's inside of the main parent level, 4D actually locks the whole thing, not just the object C, just so you know, because the whole thing is considered to be one single object. So the same thing if you want to make some modification to object B and you call use object A dot object B, the lock is actually happening at the top level as well. And once you're done, it releases the main level of the object. Okay? So, again, going back to just to simplify what you've seen, I mean, the information, the share feature is actually helpful when you're trying to pass information from one process to another. And one important point, if you think, because I had the same thoughts when I started playing with this feature. You saw that I create an object from one process and I spawn it, I pass it to another process, right? So the first process died. The second process has the reference. The second process die doesn't mean that you create a memory leak. Internally, 4D actually has a counter. Every time when you create a shared object, that counts as one. When you pass to another process, that counts as two. If one of the process was terminated, the count was deducted by one, right? Oops, sorry. By one. And then once the last one's gone, 4D deducted, so it's 0. 4D knows that it needs to dispose that shared object. So we actually thought about this, so you never have to worry about creating some kind of memory leak when you deal with a shared object. Okay, so again, let's jump to storage. I hate repeating after Laurent. I know he did a lot of discussion about this, but again, let's go over some of the things. I look at this as almost like a warehouse full of shared objects, right? Shared objects, not anything else, right? It could be shared objects or shared collections. You can't put just a new property in the storage. You can't. It has to be in the form of shared objects or shared collections. And the behavior is quite similar to the shared objects concept. That is, anytime that you want to read, you can read it directly without having to ask permission. If you want to write, that's when you call the use command to perform your write process. And the storage command is basically, it's a function. It gives you the reference to the application storage. If you are using component, your component can have its own storage. It means that your host has one storage, your component has its own storage. They are not mixed. They are not in the same space, okay? So that's one separation. Let's give another example for storage. Let's say we have 3 shared objects in there, and each one of them only contain one single property. To be able to read from it, again, similar to shared objects, we're just making a dot notation reference just like that, okay? Now, this is sort of my recommendation because the storage command function is still a function. When you do any kind of execution of a function in 4D, it has some overhead, right? Instead of making 3 separate calls to storage like that, my recommendation would be set the storage reference to a local variable and reuse the variable, right? This way it doesn't, 4D doesn't have to re-executing the same thing over and over again because the value will never change. You're already in here, so reuse the reference that you have in terms of variable is much more efficient. Okay, so the writing from into storage, again, we're using the same best practice. We assign the storage to a local variable, and we'll make a use of that storage. Let's just say I want to modify something in object A. Now, I don't have to do this, but I do this for a purpose of breaking it up. I could just say I eliminate the top part and just go directly to storage.object A, and that's okay too. But let's say I want to do this, okay? So I lock the top part and I lock object A, make some changes, okay, it's great. I call the command endUse, releasing object A. I want to do the same thing for object B, okay? Make some modification in object B property. I call the use, and then I make some modification, and that's it. So at the end, I release it. Again, like I said before, I could just eliminate line number 2 altogether and just do that. Now, it depends on what you're doing. This type of thing might be necessary if you want to make sure that you have that whole thread of the top level protected, because you could have something that you want to execute between line number 5 and number 6, which is like a big long code, right? And you don't want anyone else to have that access yet, but that's just a precaution. Again, I'm breaking this up so that you guys can see one line at a time, okay? So that's sort of the sum of the features for the storage and the share objects, and I use a different scenario and show you guys in different ways from Laurent, I know, but the concept is pretty much simple. You have something that you want to share globally, storage. You want something that you want to have a long life that you can share among different processes, go with the shared object. Yeah.
So I realize that when you're running source code, that you don't actually get multiple.
Sorry, keep forgetting. Can we get a mic, please?
Testing. So when you're running source code, I realize that it's not actually doing multiple processes. But for testing's sake, I'm curious if you're using these things and you do a violation of what you should be doing. I want to get that violation just so I know that when I run compiled, it's going to be similar. Is that the case?
Well, the storage is not strictly preemptive, right? You can run this in cooperative too. The violation has to do with when you're calling something at the wrong location. So when you test it, you'll be able to detect right away if you violate something, if something is wrong. It's not like you have to wait until running compile to find that out. So my advocacy to using storage and share object is for you to start using this, it means that you're trying to migrate your code to preemptive mode. So,
Exactly.
So that's, you start using it and then you start testing it. But again, the violation and all the error, you will be able to detect that prior to the compilation, I'm pretty sure, because just testing the code like this, you will be able to see it.
Thank you.
Can you? Sorry, I can't say. One sec.
Oh, over here. So storage is, if I'm interpreting it right, this is a way to eliminate the use of interprocess variables. If you're trying to get your application to be in a thread-safe
Right.
state, multiple processes, workers, not workers, whatever, but you want it all thread-safe,
Right.
then stop using interprocess variables and switch to storage, which is a shared object, right?
Right.
And that would be one use. I was kind of wondering why you came up with storage. Was it because of interprocess variables?
Well, to be honest, I mean, just like what I, in the slide this morning, it's an alternative to the use of interprocess variable. That's exactly what you just said.
Okay.
Except that it's allowing you to do the same thing while you want to go preemptive. Can you go to the back? I think it's just Justin.
He was answering my question.
Oh, okay. Sorry, I just couldn't hear it. Sorry.
It wasn't so much a question as answering Tony that it does throw errors in both compiled and source code when you're running through, if you mess this up and you're not using it correctly.
Okay.
But I do have a question since I have you there.
Yes, go ahead.
Are there any queue management tools?
One more time, please.
Are there any queue management tools coming for the essentially invisible queue when you pass messages to the worker process?
You don't, yeah. The quick answer would be no. You don't see or you don't have any way to manage what goes in because 4D has that its own queuing and it's just basically just manage it for you. It's like first come, first in, first out.
So what happens if you crash and you had a whole bunch of things to be done in the queue?
Well, that's kind of the same as everything else that will crash. That's that, yeah. Yeah, don't, no, but we don't have that. And I mean,
crashing?
I'm sorry.
You don't have crashing?
Well, we could think of the new event on before crash, and you can do something about it. Anyone else? Come right here. Oh, just a second.
Just real quick, what's the scope of storage with 4D server? How does that work between server and client?
Within the application. The scope doesn't go across to the clients,
Okay.
just within the application. Hopefully, right here.
Would you say the preemptive processing lends itself to all the old stored procedures that we put off to the server? Or are those automatically on their own CPU?
Well, that's the stored procedure on the server that you're talking about, the stored procedure that you create on the server. Yes. Okay. Again, this is depending on the code that you have in there. If everything is thread safe and you want it to run in its own space, you could enable that option because, like I said before, and you will use the command new process to run, right? So you could do that in preemptive mode. It means that it will go into its own CPU. There's a couple of things that you could do to change, to help the process also, because I personally would not just running a new process in a loop, like the whole, keep it, like, for example, you have a loop and you have 5 tasks running, right? Those tasks could be anything, sending email, print something, right? I would not keep it within that process. Now, this process could be something that calls a worker to perform the task. It means that each task, once it's done, is done. It doesn't interfere with anything else. So this way you can have an option to spread those 5 tasks across multiple CPU instead of, even though this one is running its own CPU, you're not really gaining anything if you have multiple things going on. So you could consider to break them up into a smaller task and send it to a worker and have the worker process individual tasks separately. Does that make sense? No?
Not in the sense that I would like to use it.
Okay.
Okay, I'll talk to you afterwards.
Okay. Anyone else? Up?
So can a 40 remote use preemptive processing?
Not yet. We are working on that. I know that we discussed about this before. Currently, multi-thread architecture only exists on the server, or if you have a standalone copy of 4D or a double-clickable, that you will take advantage of. You will be able to take advantage of that.
16-bit, or 32-bit, 64-bit, excuse me.
Yes, just not in the remote context for the moment. Anyone else? Okay. Well, thank you very much for coming, and we'll see you tomorrow.